Okay, so this is Chapter 2, Section 1, which is quadratic functions. So what we've done so far is we have talked about quadratic equations when we knew what they were, but then the question is how do you take a quadratic equation that's not in standard form and get it in standard form? So we're going to start with problem number 14. Sketch the graph of the quadratic function without using graphing utility. Identify the vertex and x-intercepts. So we have to do two things. We have to find the vertex and the x-intercepts. To do that, you have to put it in standard form. Some of them may already be in standard form, pretty close to it. So our first problem is 25 minus x squared. So it's almost in standard form. I'm just going to change it to minus x squared plus 25. So, our parent function is y equals x squared. So we've got the negative sign out front, which means that it's reflected across the x-axis. And we have a vertical displacement of 25 in the positive direction. So I'm just going to, they're just asking for sketches. Yes, without a graphing utility. So I'm just going to approximate things here. So there's no x shift, but there's a y shift of 25. So if I put 25 on the y-axis like this, it'd be negative 25. So it's going to be in the negative x direction, like negative y direction, like that. And you know it's going to be here. It starts here because when you set x equal to 0, which is along the y-axis, you get 25. And the negative signs mean it's pointing downward. Or you can think about that you have the parent function, which goes this way, and then you reflect across the x-axis, and then you shift it up to 25 units. Now the other thing, because it's going downward, it's going to cross the x-axis some point. So that's where finding the zeros of the function, which is also the y-intercept. So what we do is we set y equal to 0 and solve for x. So we say 0 is equal to negative x squared plus 25. We add x squared to both sides, so that eliminates the x squared on the right-hand side. And then you take the square root, so you get x is equal to plus or minus the square root of 25. And the square root of 25 is 5, so you get plus or minus 5. So those are the two x-intercepts. So I'm using a slightly different scale on the x-axis. This would be minus 5. This would be plus 5. So it's going to come down here, and it's going to intersect the x-axis. At that point, it's going to intersect the x-axis at that point. So that's my sketch. Okay, the next problem is 18. So this one is in standard form again. So this one should be fairly easy to sketch. So in terms of looking at this from a, where the vertex is, the vertex is basically how we shift it. So and we didn't talk about that over here, but let's specifically, the vertex of the, is the coordinate pairs 0, 25. That's the vertex. And you can get that from the original expression because there's no x shift. So this x coordinate is 0, and there's a y shift of 25. So the y coordinate is that. So again, from the standard form, the vertex is, well, I'll tell you what the vertex is, and then so it's going to be 6, 3. And the standard form of a quadratic equation is x minus h squared plus k. h and k are the coordinates of the vertex. So you can see I've got x minus 6, so h is 6. And then the number at the end here is k, so k equals 3. And the vertex is the coordinate h comma k. Now as far as sketching it, so we'll draw our simple xy axis. So the first thing you're going to do is you're going to go over 6 units. So let's say that's 5, 10, minus 5, minus 10. So this is 5, this is 10. And we'll do the same in the y direction. So this is 5 and 10. So the vertex is at 6, comma 3, which is about right here. So I go over to 5, a little more, 6, up 3, which is not quite 5. So that's the vertex. Now the y-intercept, let's go back to the previous problem. The y-intercept was, it was just y equals 25. Here it's offset. And because there's a positive sign out in front here, which means it's going to be pointing upward, there are not going to be any x-intercepts because we start above the x-axis and we go up. Now we would have we'll have an y-intercept somewhere, and you obtain that by setting x equal to 0. They didn't ask us for this, but since there are no x-intercepts, we can do the y-intercept. That's where you set x equal to 0. So the value of the function at x equals 0, which is the y-axis, is going to be x minus 6 squared plus 3, which is 39. Negative 6 squared is positive 36, plus 3 is 39. So that's way up here outside of the graph. Okay, 22. Now the next one is not in standard form, so we have to use completing the square to put it in standard form. And once it's in standard form, we can find the vertex. But one thing we can do first is the x-intercept. Before you use completing the square, if it's already in a form like this, it's easy to find the x-intercept, or the y-intercept. Easy to find the y-intercept. So it's going to be, that's where you set x is equal to 0. So the y value is going to be 1/4. Okay, so that's the y-intercept. The x-intercept, if we can factor this thing, easily, we could just factor it at this point. But we'll come back to do that because it's not obvious what the factoring is. So we'll use completing the square to get in standard form, and then you can use that to find the x-intercepts. So, standard form. So to do that, what we do is you take the function and you separate the constant term, put that over here. So we're just moving something. Okay, next you take the coefficient in front of the x term, which is 3, you divide by 2, and you square that thing. So you'll get 3/2 squared, that's 9/4. So what you do is you add 9/4 here, and to balance that you subtract 9/4 on the same side. Then you can rewrite the first 3 terms as a complete square. And what it will be this term in the parentheses, 3/2, and the sign will be dependent upon what the sign is here. If it's positive, then it'll be positive 3/2. If it's -3, it'll be -3/2. So it's going to be positive 3/2 quantity squared, and then you can simplify what you have here. So you have a quarter minus 9 quarters, which is negative 8 quarters, which is 2. So this simplifies down to negative 2. So that's standard form. So standard form is x minus h squared plus k. So h is equal to negative 3/2. K is equal to negative 2. So that's where the vertex is. It's at the point negative 3/2 comma negative 2. So that's our vertex. Now, if we set this equal to 0, we can find the x-intercepts. So this is really the same as the original equation. It's just in a different form. So here we could have set it equal to 0 and tried to factor this, or here we can set it equal to 0, and we've already got some things already taken care of. So you'd add 2 to both sides. So you'd get 2 is equal to x plus 3/2 squared. Then you take the square root, so we get plus or minus the square root of 2 is equal to x plus 3/2. Then we subtract 3/2 from both sides to eliminate that on the right-hand side. So you get negative 3/2 plus or minus the square root of 2 is equal to x, or x is equal to negative 3/2 plus or minus the square root of 2. And if you do that in decimal form, you'll have negative 3/2 minus the square root of 2, and I get negative 2.91, and the other x-intercept is negative 3/2 plus the square root of 2, so that's negative 0.086. So we've got the y-intercept, we have the vertex, and we have the x-intercept. So now we just need to sketch the graph. So we take our axis, and because of the scale that we're talking about, we have negative 2 to approximately negative 0. So I'm going to draw this with 3 units on this side and 3 units on that side, and each one's worth 1 unit. So this would be negative 3, negative 2, negative 1. This would be 1, 2, 3. And I'm going to do the same scale in the y direction. So this is plus 3 in the y direction. This is negative 3 in the y direction. Okay. So let's look what we have. Let's plot the vertex first. So it's negative 3/2, negative 2. Negative 3/2, negative 2, put you about right there. So that's the vertex. Because this is positive, it's going to go up, which we knew anyway because it has to have x-intercepts. We could draw a line of symmetry. Let's do that. So if we draw our line of symmetry, it's going to be symmetric around this vertical line of the vertex. It's going to intersect about here, which is really close to 0, negative 0.086, and it's going to intersect at 2.9, which is about right there. And then it's going to have a y-intercept of a quarter, which is about right there. So if you take this, you have the minimum goes up here, and I don't have these things drawn exactly, but and then you'd have the other side, which would go through here, and then be symmetric on either side, something like that. So that would be your solution for that one. Okay, 26. Okay, another one that is not in standard form. So we're going to have to do that. 2x squared minus x plus 1. So first thing you know is the y-intercept is y equals 1. If you set x equal to 0, these two terms go to 0, so you get y is equal to 1. Again, we'll do the x-intercepts later, but we're going to first put it in standard form. So again, we're going to use completing the square. It's a little bit different here. What we're going to do is we're going to factor out a 2. So 2, factor 2 from this, you divide by 2. And the same way here. So if we divide by 2, we'll get negative 1/2 x. And then the constant comes out here. So we've just factored out the 2 for the first two terms. We've just then separated them. Okay, so what you do is you take the coefficient, negative 1/2, you divide that by 2, and you square it. So what is it if you divide by 2? You get negative 1/4, and you square that, which is positive 1/16. So that's the number we had here, plus 1/16. So we have to subtract 1/16. Oh, actually, we have to subtract more than that, because if you ever have to factor out a number because the coefficient in front of x squared is other than 1, you have to realize I add a 16th inside here, but I'm multiplying it by 2, so I'm actually adding an 8. 2 times a 16th is an 8. So if I add an 8, I have to subtract an 8. So this, completing the square, you have your 2, and you have x, and then we're going to take the expression inside this parenthesis, before it's squared, is negative 1/4, that whole thing squared, plus the constant, which is 1 minus 1/8, which is 7/8. So the standard form, so far we've said it's equal to x minus h squared plus k, but it's really, there's an a outside, and it just turns out in the previous examples a has been 1, but it's not the case here. And what this does is it stretches or shrinks the drawing. Okay, so now we can do the vertex. The vertex is the coordinate pair h, comma k, which in our case is 1/4, comma 7/8. Now to find the y-intercepts, the x-intercepts, we set this equal to 0 here. So you get 0 is equal to 2 times x minus 1/4 squared plus 7/8. So what we do is we subtract 7/8 from both sides. Like that. And then we take the square root, and we're, something's wrong, because I can't take the square root of a negative number. So what does that mean? Well, another way we could look at it is that the vertex is above the x-axis, and if it's going to go upward, which it will if this coefficient here is positive, there's no x-intercepts in this case, for two reasons. One, just thinking about it visually, and secondly, you end up with the negative square root of a negative number, which we can't do. So now we'll sketch it, and you kind of have a limited amount of detail that you can put for a graph when your vertex is above the x-axis and it points upward, or it's the other way around. So I'm going to, again, just do 3 ticks here and 3 ticks there, and 3 ticks that way. Yeah, same down this way. So each one's worth 1 unit. So we do have the vertex. It's a quarter, which is about right there, and 7/8, which is about right there. We do have the y-intercept, which is 1. So it's right there. And so we know we've got a point right about there that's 1. And then it's going to go like this, upward. And it looks like it's, well, it's probably actually, I think, a little shallower than the normal quadratic function. Or is it steeper? I think it's steeper because you've got a 2 in front here, so it's actually going to be a little bit more steep than a normal quadratic function. Something like that. So we don't have the x-intercepts to help us draw the curve. Okay, so that was 26, 30. So I think I'm going to do two videos here. This is going to be the first part. So 30, we have the function f of x equals negative x squared plus x minus 30. And what it's asking us to do is use a graphing utility to graph the quadratic function, identify the vertex and the x-intercepts, then check your results algebraically by writing the quadratic function in standard form. So I'm actually going to do it the opposite way. We're going to do it analytically, and then we'll go to the graphing program and check out how well they match up and verify the points. So what I'm going to do here first is I'm going to keep the negative sign factored out. But I'm going to take the 30, which is inside the parentheses, I'm going to multiply it by -1. So negative times the negative 30 is positive 30, so that's going to come outside by itself. Okay, then to find the value, to complete the square, you take the coefficient in front of x, which is 1, you divide by 2, you square it, and you get the answer 1/4. So we're going to add 1/4 here. And but we have to reflect the fact there's a negative sign out front. So we're really subtracting 1/4. So we add 1/4 at that point to the other part to balance out the two things. So this can be rewritten as x plus 1/4 squared. And then we have 30 1/4. It's just slightly more than 30. So that's in standard form. Now, as far as the x-intercepts, it's going to be interesting. So the x-intercepts, we set y equal to 0. And I'm just going to put 30.25. So we'll do it in decimals here once we'll change that to 0.25. So at the vertex, we didn't talk about that. The vertex is at negative 1/4, comma 30 1/4. A is -1, so it's going to point downward. The vertex is actually below the x-axis. And if it's pointing down, then we're not going to have any intersections. So let me just explain what I'm doing here. So if you go, no, actually it's above the x-axis, right? Yeah, sorry. So it will have some x-intercepts. So this is, the x value is negative 1/4, so it would shift to the left 1/4 of a unit, and it's going to go up 30 units, so it is above the x-axis. So there are x and y intercepts. So we set that equal to 0, so then you subtract 30.25 from both sides. And then you take this, you multiply both sides by -1. Then you take the square root, so we get plus or minus the square root of 30.25 is equal to x plus 0.25. We subtract 0.25 from each side and switch sides, so you get negative 0.25 plus or minus the square root of 30.25. And then we'll just do that in decimals, so negative 0.25 minus the square root of 30.25. So that's negative 5.75. And the other one is where we add the square root. So that's positive 5.25. So let's sketch it out, and then we'll go plot it. Actually, let me just draw the axes here. Okay, so here we go. And the vertex is somewhere here. It's at 30 comma a quarter, and essentially zero, close enough to 0. So let's make each unit in the y direction 10. So this would be positive 30. This would be negative 30. And in the y direction, let's go plus or minus 10. So this is 5 units, negative 5, negative 10, positive 5, positive 10. So the vertex is 30.25, 30.25y negative a quarter x. So negative a quarter, which is really small, 30.25 going to be right there. So that's my vertex. It's going to point downward. We're going to have a x-intercept about right there, and one a little bit to that side because it's slightly to the left of the origin. So we're trying to make it symmetric about that line, our axis of symmetry. And we will have a y-intercept, so let's go back and figure that one out. So if you set x equal to 0, you'll get 0 plus 0 minus 30, which would be negative 30. With the negative sign, so it becomes plus 30. So the y-intercept is going to be right there. So that, and then I'm going to have something symmetric on the other side like that. So it looks kind of like this. Goes back around like that, and loops down. Okay, so there's a graph. Let's go to the graphing program. So our original equation was negative the quantity x squared plus x minus 30. And what we'll do is we'll have a y minimum of negative 40, y maximum of 40, and x minimum of negative 10, and a x max of positive 10. We'll graph that baby. So there it is. So they're getting, it looks like their vertex is 0.5. So what did I do wrong? Let's go back here. Oh, I just wrote the number wrong. So I don't know whether you caught that or not. This should be a half. So let's go back and correct all these things. So this is this should be plus 1/2. So this will be negative 1/2, and that should be a half. And that becomes a half. That becomes a half. That becomes a half. That becomes a half. And these will be something else. So here we get 0.5 or half. I'm going to put it as a decimal. 0.5, 0.5, 0.5. So you get negative 0.5 plus or minus the square root of that. And so the square root of 30.5 is 5.5. So this ends up being negative 0.5 plus or minus 5.5, which is x equal, if you take a negative, you get negative 6, and if you take the positive, you'll get positive 5. So those are my two, that's my two x-intercepts. So you can imagine making that slightly different. This will be 6, and this will actually go through there. And so if we go back to the graph, you'll see now it works. So here's the vertex at 30 point whatever. What was it? 30.25. Okay, so if we zoom in right there, you'll see the maximum is right here. 30.2425. Okay. And how did I get back to where I want it to be? Let's go there, and I'll zoom out a little bit. Like that. I'll zoom out a little bit in that direction. Okay. So that's the vertex. The intercepts are negative 6, positive 5. The y-intercept is 30. Okay, so that's it for that group. Okay, so this is the second half of section 1, chapter 2. So let's see, we were on 30, so this is 32. So 32, 34 are plotting the function. And since I made an error on the last one, I'm just going to plot it first so I don't make another error. We'll look at it first and then we'll confirm it is what it says it is. So this is the function x squared plus 10x plus 14. Okay, so let's plot that. So it's x squared plus 10x plus 14. And we'll graph this thing. And we'll zoom a little bit out in the x direction, like that. That's good. So you see the vertex is about negative 5, comma, negative 11-ish. We have two x-intercepts around negative 8 point something and negative 1 point something, and we have a y-intercept of, it looks like about 13-ish, 14. I guess it's 14. Okay, so that's the function. Now, let's confirm what we know here. So we need to put it in standard form. But first, before we do that, we can find the y-intercept. So that's when you set x equal to 0, and when you do that, you get y equals 14. So that's my y-intercept is 0, 14. We'll put it in standard form, and then we'll do the x-intercepts. And it looks like they're not integers because you can think about 2 times 7 is 14, but 2 plus 7 is 9. So I don't think it's going to work out to be a nice integer like we did on the last problem. So standard form, you take the first two terms, kind of isolate those a little bit, put the constant over to the right, take the coefficient in front of the x, divide by 2, which is 5, square it, which is 25, so add 25, and we subtract 25. Then we make this into a complete square. So you get x plus, take this number, 10 divided by 2, which is 5. Whole thing squared. And 14 minus 25 is negative 11. So that's the standard form. So we know the vertex is going to be at x equals negative 5, y equals negative 11. Next, we set that equal to 0. add 11 to both sides. Take the square root. Subtract 5 from both sides. So you have negative 5 plus or minus the square root of 11. In terms of decimals, plug those in there. So you'll have negative 5 minus the square root of 11. Which is negative 8.32. And we add the square root of 11. And we get negative 1.68. Now, notice the x-intercepts are always symmetric around this number negative 5 because we go one direction a certain distance, we go the other direction a certain distance. So this one is 3.32 to the left of that, and this one's 3.32 to the right. So we got everything we need. We have vertex. So let's actually take a picture of the curve that we just had, and we'll plot everything on there. So where's my camera? Here it is. Okay, so we're going to go over to the graph. We're going to click there. We're going to go like that. Save it to my notes. So there it is. So let's confirm that everything's as expected. So our vertex is right here. It has coordinates of negative 5, negative 11. Here's the two x-intercepts, 8 point something. Let's go down and look at the scale here. So, you know, the line of symmetry, x of symmetry would be the line x equals negative 5. We have y-intercept here, which looks like around 13 or something. What's the original expression? 14. So everything matches. And then we have this point of symmetry here that we could put right over there if we wanted to. Okay, 34. So we have f of x equals negative 4x squared plus 24x minus 41. Okay, so we're gonna plot that. I'm gonna actually go ahead and grab the picture first, and then okay, it's gonna be pointing down because you got a negative 4 in front of there. Okay, so let me just do this. Negative 4x squared plus 24x minus 41. So there it is. So it's not going to have any x-intercepts because it's below the x-axis. We have a y-intercept of negative 41. We have this point of symmetry here around that. The axis of symmetry looks like it's going to be around x equals negative, the positive 3. Okay, so let's take a picture of that. So there it is. Okay. Y-intercept. Set x equals 0. You get y is equal to negative 41. So that's that point right there. We're going to put it in standard form. So what do we do? Well, we factor out a negative 4 out of the first two terms, so that'll leave x squared. And if you divide 24 by negative 4, you get negative 6. So we get negative 6x. And then we leave the other one by its lonesome. Okay, so now to complete the square, we take our coefficient in front of the x, we divide by 2, we square it, so you get negative 6 divided by 2, which is negative 3. Negative 3 squared is 9, so I add 9 here. And I'm adding 9 inside the parentheses, but I'm really adding 36. Well, I'm subtracting 9. I'm subtracting 36, so I have to add 36. So if we put that in standard form, you get negative 4 times x minus 3 squared. This term here is just term in the parentheses, negative 6 divided by 2, negative 3. And then we get negative 5. Okay, so that's standard form. So the vertex, which is x minus h. So h is positive 3, and y is equal to negative 5. So that's the vertex. So that's that point right here. So that point will be 3 comma negative 5. Okay, now because it's pointing downward, and you can know that from various reasons. One, because of the negative coefficient in front of the x squared term. Also because the y-intercept's down here. You could prove that. The other thing is if you tried to solve this for x, so you set y equal to 0, you get negative 4 times x minus 3 squared minus 5. You add 5 to both sides, so you get 5 equals negative 4 times x minus 3 squared, and you divide by negative 4, so you get negative 5/4 is equal to x minus 3 squared. Well, then when you try to take the square root, you got a negative sign there, which is not possible. So that means there are no zeros to this equation. And the last point you could do is you could go, so this is y equals, or x equals 0. And this is x equals 3, so if you go to x equals 6, and then come down to this same y value, negative 41, you could plot those 2 points, and then you would have the vertex and 2 other points to give you some kind of guidance in terms of drawing your picture. Okay. That was 34. Okay, now we're moving on to a different kind. It says, find the quadratic function that has the indicated vertices and whose graph passes through the given point. So you've got 46, which says vertex is the point negative 2, negative 2, and it goes through the point negative 1 comma 0. So what you can think about is, in standard form, f of x equals a times x minus h squared plus k. So from the vertex, we know that h is negative 2, because that's what x is in the vertex. So you're going to end up with a times x plus 2 squared. And then the y coordinate of the vertex is negative 2, so that's equal to k. Then to find a, you take the point that you're given. So we're given the point x equals negative 1, and y is equal to 0, x, y. So if we subtract, what we do is we'll, first thing we'll do is we'll figure out what this expression is. So you get 0 is equal to a times 1. 2 minus 1 is 1 squared. So that just becomes 0 is equal to a plus 2. 1 squared is 1. A times 1 is 1. And then you subtract 2 from both sides. So you get a is equal to negative 2. And therefore, the function is negative 2 times x plus 2 squared minus 2. And you can double check here by plugging in your x and y value, x values, and make sure it's the y value. So it says when x equals negative 1, y should be 0. So if you plug -1 in here, you'll get -1 plus 2, which is positive 1. 1 squared is 1. 1 times -2 is -2. And what did I do? Oh, yeah, I just found out I'd made a mistake. So it show you sometimes it's good to do these things. So I think A is actually positive 2. So this was negative. I wrote it down wrong. So this is negative. That's negative. So that's positive. So this A is positive 2. Okay, now we'll check it out again. So if you plug x equals -1 in here, you'll get -1 plus 2, which is positive 1. Positive 1 squared is positive 1. Positive 1 times 2 is 2. 2 minus 2 equals 0, which is what we get. So f of -1 is 0. Okay, 87. So these are word problems. It says the number of horsepower Y required to overcome wind drag on an automobile is approximately equal to Y equals 0.002 s squared. So we could say f of x, which is Y, is 0.002 s squared plus 0.005 s minus 0.029, and s is between 0 and 100 miles per hour. Use the graphing utility to graph the function, graphically estimate the maximum speed of the car if the power required to overcome wind drag is not to exceed 10 horsepower. Okay, so let's just plot this thing first. So the function is 0.002, and I'm using x because I can't use s in this program. X squared plus 0.005 x minus 0.029, and we're probably going to have to change the value here. So let's zoom in the y direction. Okay, and it says so it says the horsepower is not to exceed 10. So this is the speed. So we're going to have to zoom out in the y direction, and then we zoom out in the x direction and the y direction. Well, I'm going to zoom out to 10. Well, so there's 10 in the y direction. So now I need to zoom out in the x direction. Okay, so there we are. So you can say it's approximately 70 miles an hour to get 10 horsepower. So that's the estimate, 70 horsepower. So how do you do that in our case? Well, what you do is you set f of x equal to 100 or 10, and then you have your equation, and then you solve for the values of s where this equation is satisfied. So typically what you do is you would put everything on one side. So I'm going to subtract 10 from both sides. So that's going to be minus 10.029. So I've got negative 10, negative 10. Now, the best thing to do is, I can divide or multiply by any number to make this easier. So what I'm going to do is I'm going to multiply by whatever 1 divided by 0.002 is. 500. So if I multiply by 500, what that'll do is it'll make this coefficient go to 1. So this times 500 is 1. 0.005 times 500 is 2.5. And 10.029 times 500 is 5,000. 14.5. So that's my equation I want to find the x zeros for. So I have s squared minus plus 2.5s minus 50.1, or not 50, but 5,014.5 equals 0. So I use completing the square. So I take 2.5 divided by 2, and I square that. And what do you get? 2.5 divided by 2, 1.25 squared. So what is that? Let's do this in fractions. This is 5/4 squared. So it's 25/16. So right over 25/16 is this number I'm looking for. Okay, so you get s squared plus 2.5s plus 25/16 minus 5,114.5. I'm adding 25/16, so I'm going to subtract 25/16. And the term that this becomes is 5/4, so I get s plus 5/4 squared. And so you get negative 5,014.5 minus 25 divided by 16, which is 5,016. 0.625 equals 0. So we add this to both sides. So you get s plus 5/4 squared is equal to 5,016 approximately. And then you take the square root, so you get s plus 5/4 is equal to the square root. Plus or minus, we're just going to use the positive one because we only deal with positive s. So if you take the square root of that, you get plus, we're going to use the plus side, 70.82 s plus 5/4 equals that. So you subtract 5/4 from both sides. So we take 70.82 and subtract 5/4, and we get 69.57. And that's miles per hour. So you go back to the graph, and we're going to zoom out just a little bit. And so what we're looking for is, where does this thing intersect 10? So if we zoom in right here, you see I've got 10. I'm going to zoom in a little bit further. So here's 10. We come over and look for the intersection of that, and we get 69.572. And how does that compare? 69.57. So that works out. Okay, the last problem is 88. So what we have is we have some data. A study was done to compare the speed with the mileage. Use the graphing utility to create a scatter plot of the data. Use the regression feature of the graphing utility to find a quadratic model for the data. Use the graphing utility to graph the model in the same viewing window as the scatter plot. Estimate the speed for which miles per gallon is greatest. Okay, so we're going to use Excel for that, and I'm not sure what Excel version you have, but so let's open up Excel. Okay, So what we're going to have is we're going to have the x-axis here, 15, 20, 25. I'll just type them in now. Okay, so those are my miles per hour. And then I have my mileage. So that's my data. And then you can go to Insert, Scatter Plot. We're just going to plot the dots right now. And we're going to move the chart to a separate page, which we'll call Chart 1. So there's my graph. On the x-axis we have speed, on the y-axis we have mileage. Delete the legend. And then if you click on the data set and then you right click, it says add trend line. So that's my regression. And we're going to do a polynomial of order 2, that's quadratic. And we're going to display the equation on the chart. And I think that should work. So there it is. There's my graph fit. And let's click on the equation and make it bigger. So I'm going to highlight the equation. I'm going to go over here to font. I'm going to make it bigger. So that's the actual equation. And I guess we're done, really, because we've done the scatter plot. We have the only thing we have left to do is estimate the speed for which the miles per gallon is greatest. So if we go here, it looks like it is about, the maximum is about right there, which would be down there. So that's the estimate. Now you could actually get the exact value by finding the x and y coordinates of the vertex for this equation, put it in standard form, but they didn't ask us to do that. So that's it for this section.